Okay, so in this video, we're going to talk about Charles' law. Okay, so it's in the same learning competency, which is to use the gas laws to determine pressure, volume, or temperature of a gas under certain conditions of change. So the Charles law is discovered by Joseph Louis Gay-Lussac in 1800. He referenced the unpublished work of Charles in 1787. That's why it's not credited to Gay-Lussac. Okay, that's why it's called Charles' law. Okay, so Charles had found that oxygen, nitrogen, hydrogen, and carbon dioxide and air expand to the same extent over the same 80 degrees interval. So Charles' law gives the relationship between volume and temperature if pressure and amount of gas are held constant. Okay, so again, Charles' law, volume, and temperature.
Let me actually write this down.
Gay-Lussac, when doing the experiment, found this to be true. He said that if the volume of a container is increased, the temperature increases. He also said that if the volume of a container is decreased, the temperature decreases. We can say that the volume is directly proportional to temperature given that pressure and amount of gas are constant. With this, we can say that volume over temperature is equal to K, where K is a constant. Let's try to derive Charles' law. So, in an experiment, when the volume or temperature change, we will have the initial, right? So we can say that there's V1 over T1, which is equal to K, or a constant. Now, when they change, we will have the final volume or temperature. So we will have V2 over T2 equals K, right? Since K has the same value, we can substitute the value of the second K to the first K,
I said what I said.
giving us V1 over T1 is equal to V2 over T2. So this is Charles' law.
Very powerful.
And since students are not fond of fractions, we can manipulate this by cross multiplying them. We will get this equation. V1 times T2 is equal to V2 times T1. Now, you have to make sure that you have the right subscripts. So it's V1 T2 is equal to V2 T1. Okay? Or if you're not really good at that, just use the fraction. Okay? I think, I, I mean, you'll get the same answer, right? And besides, you have the scientific calculator, right?
We on the same page, right? I know we are.
So again, temperature must be in Kelvin and not degrees Celsius, please. So you can see in this animation, when the volume increases, the temperature increases, given that the mass and the pressure are constant. So let's solve some problem. Let's start with an easy one. So a gas is collected and found to fill 2.85 liters at 25 degrees Celsius. What will be its volume at STP? Okay, so the given is initial volume and temperature, 2.85 liters at 25 degrees Celsius, right? And we're looking for the final volume, V2. And if a gas is at STP, the temperature is at 0 degrees Celsius. And since it should be in Kelvin, we have to convert this to 0 plus 273. We will have the temperature, or T2, as 273 Kelvin. Now let's convert the other temperature, T1, to Kelvin. So 25 plus 273, we will have 298 Kelvin. So now we can use the formula V1 over T1 is equal to V2 over T2. So just put the given 2.85 liters over T1, which is 298, is equal to V2, since it's unknown, over 273 Kelvin. Okay, so solving for it, we'll have 2.61 liters. So now let's try solving this using the manipulated formula. So we have V1 T2 is equal to V2 T1. Just insert all the values given. 2.85 times 273 is equal to V2 times 298. Solving for V2, so we'll have this equation and you will get the same answer. Okay, very easy, right? It's simple.
Kahit anong gawin nyo sa akin, patayin nyo pa ako, hindi ko makukompute yan.
A different problem. If your volume temperature constant is 0.432 milliliter over Kelvin, what would be the volume of your sample if the temperature is at 35 degrees Celsius? So the given is the constant. This is the K, which is 0.42 ml per Kelvin. Another given is the temperature, which we have to convert to Kelvin. So 35 plus 273 is equal to 308 Kelvin. Now we're looking for the volume. So let's use this equation. V over T is equal to K. Substitute the values. Volume is in the numerator and temperature, 308 Kelvin, is equal to 0.432. So multiply 0.432 by 308. So Kelvin will cancel. This will give us 133 ml. So in liters, it's 0.133 liters. So we have the same significant figure. So this will be our final answer. Okay. Some problems will require your answer or your final answer to be in milliliters or in liters. So just know the conversion. Okay, let's have this, a more challenging problem.
No, no more. Stop here. Okay. Loses?
So in an air-conditioned room at 19 degrees Celsius, a spherical balloon had a diameter of 50.0 centimeters. When taken outside on a hot summer day, the balloon expanded to 51.0 centimeters in diameter. What was the temperature outside in degrees Celsius?
Kahit anong gawin nyo sa akin, patayin nyo pa ako, hindi ko makukompute yan.
So let's dissect the problem. So we know that the temperature is 19 degrees Celsius and it's a spherical balloon and with the diameter of 50.0 centimeters. So the diameter changed into 51 centimeter and we're looking for the temperature. But sir, we don't have diameter in the formula.
None. None.
But remember, in your geometry, you have the formula to get the volume of the sphere. So let's have the formula first. V1 over T1 is equal to V2 T2. But I prefer using the V1 T2 is equal to V2 T1 because I hate fractions. Okay, so since we're looking for temperature, the final temperature, I mean, so we can have this formula V2 times T1 over V1, right? And we know that the volume of sphere is equal to 4/3 pi r cube. We can substitute this to V, okay? So we will have 4/3 pi r cube times T1 over 4/3 pi r cube of volume 1. It sounds so complicated, right? But notice that they will just cancel out.
But wow, what a moment.
Okay, so don't be afraid with all the fractions and pi. So we will have this formula. Radius 2 cube times T1 over radius 1 cube. So just putting on the numbers, we will have 25.5 centimeters. The half of diameter is a radius. So we have to divide the diameter by 2. Then use it. Okay, so again, going back, we have 25.5 centimeter cube times 292.15 Kelvin over 25.0 centimeter cube. Since we're looking for Celsius, degrees Celsius, we have to minus or subtract 273.15. So solving for this, we'll have 36.88. And since the givens have three significant figures, the final answer will be 36.9 degrees Celsius.
It never ends well for me in my mental state. So